Imagine a robot handshake with just the right squeeze. Not a vice grip, not a floppy noodle. That's the dream. But the reality? Most robots out there couldn't tell your hand from a baguette if their job depended on it. Here's the awkward truth. Robot fingers don't feel much. Sure, you can bolt on sensors, but soon you're building sensor sandwiches, thicker than the robot itself, and nobody signed up for a robot club sandwich. Now, a team led by BioBytee and colleagues has added a new twist, actually, a new trench to the mix. Instead of stuffing more sensors into those robot digits, they carved tiny micro-trenches right into the soft covering. When the robot finger presses something, these microscopic grooves make the tiniest indentations light up, visually, to an overhead camera. Think of it like adding miniature speed bumps for light. Suddenly, subtle touches and soft thuds show up like neon traffic signs. The camera, teamed with a lightweight neural network, maps out exactly where the finger was poked, down to less than 0.05 millimeters. That's finer than a frustrated cat's whisker twitch. No weird wires, no sensor lasagna, just brushed-on patterns that turn pressure into bright, juicy visuals. The neural network skips the usual data overload and only needs a quick look to spot where contact happened. Why should you care? Delicate handling means robots could someday sort ripe fruit, hand you a cup of coffee, or work side by side with humans, all without accidentally squishing anything or anyone. It's a little step towards robots that can act with a gentler touch, like the world's most careful barista. The detail worth slowing down on is the bottleneck. This idea is instantly visual, but the paper matters because the researchers are not just showing a cool object. They are asking whether the weakest part of the system can be redesigned. That is usually where the real science is hiding, not in the shiny final demo, but in the annoying constraint that kept breaking the design before. A useful way to read vision-based tactile sensing, enhanced by microstructures and lightweight convolutional neural network, is to separate the headline from the mechanism. The headline is what makes you click. The mechanism is what decides whether the idea survives after the first 10 seconds. The quick version is simple: how microstructures make touch visible. Here, the more important question is, what did the researchers change, and why would that change make the system more reliable? When you loudly point out a tiny typo in a group chat, and everyone definitely notices. So, would you trust a robot to hand you your favorite mug now? Let us know below.